Hi, my name is Dipesh Dhingra and I am the exhibition leader for Engineering and Applied Sciences, and today we're in for a special treat because we've got not one, not two, but 8 different projects from Stevens Institute of Technology. These are seniors in the mechanical and electrical fields, and they have come here with their senior projects and they're displaying them for one whole week, and we're going to have them here till Friday, June 3rd.
Hi, I'm Shannon Pierce. I'm a mechanical engineering student that just graduated from Stevens Institute of Technology. Right behind me we have the brisk water filtration system. It's completely man-powered. It's a pedal system. So the water comes through from a tube that they put into the water source by where they live, and first goes through a coarse filter, which is where all of the larger particles get removed, and then it goes through an ultra filter, which filters down to 50 nanometers, getting rid of 99% of bacteria so that they won't get sick. We've sold 3 units already, and it's going to be manufactured in Panama. There was an original system that weighed 500 pounds, and this new system now weighs about 140. So we reduced cost and reduced weight, and also the seat part of the system folds up and it makes the system act as a trolley so you can move it from location to location. So I've always loved math since I was younger. I was originally a math major, but then I also sing and I act, and I was like, okay, well, I don't know what I can do with math in that field. I went to go see a Broadway show, and it was the Newsies, and their set was robotic and automated, so I figured, okay, well, worst case if I don't perform, I can design the sets of Broadway and concert stages through mechanical engineering. I feel like mechanical engineering is probably the most broad type of engineering. You can do almost anything with it. You can get into sustainability, you can get into helping people like this, you can get into technology. There's just so many different applications, so you really can do whatever you want. But I would say for my project specifically, I just love that it's not just something that's like being manufactured and can get thrown away somewhere. It's actually helping save lives.
So my name is Dan Sheedy. I'm a student at Stevens Institute of Technology. I actually just graduated with my mechanical engineering undergrad. Basically, we got a prompt in the beginning of last year, and it was to make an automated garter. That's all we got, like one little sentence. So me and my team of 5 people, so we came up with this, which is kind of like a localized automatic farmer. So this prototype now, it plants a seed with fertilizer, and it waters that seed, and it can maintain that watering system for as long as it needs to grow the crops. The coolest part I think about this project is the seed capsule designs, which is basically a water-soluble seed capsule that can have any sort of seed inserted in it along with fertilizer to promote the growth. So what that does is it standardizes the size of the object that the robot needs to interact with, and that's really important in any kind of robotic operation, because having a lot of variables is hard for robots, especially when you're on the scale of like a senior design project. Obviously, the more high-tech stuff can do almost anything. But for us, we want to keep stuff standardized, and we thought if we were to make like a business model out of that, selling those seeds might be kind of a cool idea. But there's a lot of options for this thing.
My name is Damian Suarez. I'm a computer engineer at Stevens Institute of Technology, and my project that I'm working on is the mechanized Ordinance carrier loader. Originally, for the Navy, to get onto the aircraft fleet, we need to load bombs onto airplanes, and originally we need multiple sailors in order to take a mechanized skid and be able to drag the bomb underneath the airplane properly and have several men lift up the place. This 5,000-pound payload that's very heavy to do. Our team has designed a different kind of mechanized skid that's able to move on its own in any direction that it needs to in order to line up properly underneath the aircraft wing and then lift up into place, reducing the workload of several sailors down to 1. In civilian life, we was especially looking at the different designs of the mechanism wheels and have it be able to maneuver out into different places. So perhaps with a different system, instead of having this little prototype that's just guiding around the bomb, we can use them into different kinds of vehicles like modern cars that will be able to self-drive around and be able to move around into different places, unlike otherwise possible when driving around cars.